We intuitively experience our cities, our societies, and our physical spaces as a rigid, static container, a collection of finished, solid results. Because of this intuition, we try to solve problems by rearranging physical objects within that space. Yet, no matter how many pieces we swap or policies we rewrite, failing systems persistently resist these changes. Anton Pankratof's observer-dependent theory of everything, or ODTO, suggests the environment has no ontological independence. It is not a pre-existing place. Pankratof defines reality as a configuration, a specific mathematical point in a vast space of potential that only springs into existence through the act of observation. When we reduce our surroundings to a simple collection of physical results, we overlook 5 invisible forces that determine how these configurations remain stable. To understand why we stay trapped in failing systems, we have to look past physical objects and dissect the mathematical structure of our collective perception. The first hidden property is called inertia. A configuration resists change because of the total cognitive belief invested in it by its observers. Inertia is total cognitive coherence. The more observers believe in a state, the harder it is to change. This creates density, the number of observers multiplied by how tightly their observations are synchronized. A configuration held by 1,000 highly synchronized minds requires exponentially more energy to destabilize than one inhabited by 10,000 fractured, desynchronized observers. This density exerts an attraction, pulling observers toward the most stable, tightly packed configuration in the network. Societal gridlock is a symptom of this immense mathematical inertia, a state where too many minds are securely locked into validating the current reality. Diverging from the collective state triggers selective pressure. The environment systematically filters out and ignores observers incompatible with the general configuration. This filtering is an automatic consequence of collective probability, which strengthens coherent variables while zeroing out anomalies. Those who remain are caught in the fourth property, self-replication. This is a non-linear attractor loop where the observed reality dictates the observer's belief. As observers see a configuration, their belief adjusts to match it, reinforcing that exact configuration to reproduce indefinitely. This is an absorbing state, a closed loop mathematically requiring external intervention to exit. That intervention is the fifth property, second order. This refers to a meta-configuration that contains the operators necessary to create new configurations. By managing the synchronization parameter, a second-order environment can decouple observers from the current attractor. It provides a quiet drafting space where the underlying rules of observation are rewritten before a new reality is projected. We are not struggling against a static physical world, but within a self-replicating loop built from our own collective validation. ODTO formalizes the environment as a 6-dimensional mathematical address: configuration, inertia, potential, density, selective pressure, and the second-order meta-operator. This framework explains why it is so difficult to fundamentally change our world. We have spent centuries attempting to manipulate physical objects while ignoring the underlying potential landscape and the inertia of collective belief. Adjusting even one of these 6 parameters directly alters the observable configuration we inhabit. Generating a new environment requires us to mathematically restructure the potential landscape, making old configurations unstable while clearing a path for new attractors. True change is found in shifting the parameters of what we collectively expect to see when we look at the world. Environment design is reality design. By mastering the mechanisms of collective observation and utilizing meta-operators, we can move beyond existing loops and architect a new mode of existence.